All right, here's a good question where they're asking you to draw the following cell and label the reduction reaction, oxidation reaction, label the strongest reducing agent, strongest oxidizing agent, etc. Okay, so they tell me that the cell is this. Now, down here, they actually have cell notation where they say that when you look at it, like up here, this first thing is your anode, then the electrolyte that goes in the anode, and then they have the electrolyte that is in the cathode, and then what the cathode is. So you could just look like this person's done up here. They've labeled that as the anode, label that as the cathode, and you can do that, or you can just look to see what you have. So like we've done here, cadmium sulfate separates into cadmium ions and sulfate ions, and then the nickel does the same thing, separates into nickel ions and sulfate ions. So basically you've got cadmium and cadmium ions and nickel ions and nickel solid. But you got to figure out which one's going to be the anode, which one's going to be the cathode. As opposed to the notation, it says anode, but we can figure that out by the chart. So let's look on our chart to see if we can find cadmium and nickel. Okay, nickel here. Oh. Shoot. Okay, sorry, I paused there. All right, so there's nickel, and where's cadmium? CD. Oh, there it is. It's right below. So there's the cadmium row. Notice it has the ion and it has the solid. Ion and solid. So both of those are in. So when you have your beaker, there's your beakers up there. When you have your beaker, you'll have an electrode, which will be the solid, and you'll have your electrolyte that's in there. But now you got to figure out which one's going to be your anode, which one's going to be your cathode. We're betting on this, what you've got there, but let's see what happens. So, since nickel is highest on the chart, I like to sort of say that that's the king hill. And as you go up the chart on this side, your oxidizing agent becomes stronger and stronger. So the strongest oxidizing will be highest on the right, and the strongest reducing agent will be the lowest on the right. Did I say highest on the left? So SOA highest on the left, SRA high or lowest on the right hand side. So that means that nickel is my strongest oxidizing agent, and not nickel solid but nickel ion, and cadmium solid is going to be my strongest reducing agent. So the reactions that'll happen, this reaction, the strongest oxidizing agent reaction, the nickel 2 plus an electron yielding nickel solid, that'll be the reaction that is happening. So the nickel ions will pick up an electron. Actually, they're going to have to pick up 2 electrons to form nickel solid. And then cadmium, since it's the strongest reducing agent, you have to flip that one. So it'll be cadmium as a solid breaks up into cadmium ions plus 2 electrons. Okay, so now this one here is gaining electrons. So they're gaining electrons, they're adding electrons. So that's the reduction reaction, and that always happens at the cathode. So GERC, gain of electrons, as reduction happens at the cathode. So I like to write my stuff with the anode here and the cathode there. So I'm going to draw another beaker, another electrode here. This would be my cathode, this electrode here, and the cathode will be made of nickel. So this is a nickel solid cathode, and I'm going to have nickel ions as an electrolyte inside there. Okay, so the reaction that's happening there is nickel is picking up some electrons to form nickel solid. That's the reaction that's happening there. That is, it's gaining electrons, so that's a reduction reaction. And nickel 2 plus is my strongest oxidizing agent. Now going on to the other one, cadmium, here it's losing electrons. So cadmium started here and it's lost electrons, they're gone. And so that reaction happens over here. So cadmium as a solid goes to cadmium 2 plus 2 electrons. So this is a loss of electrons. Loss of electrons is called oxidation, and it happens at the anode. That's how I remember Leo A and Girk. So this guy here has to be the anode. So this cathode right there, that's the not cathode, this electrode right there is made of cadmium, and there'll be cadmium ions floating as an electrolyte in the solution there. Now to make things go, you need a salt bridge, right? So there's my salt bridge, and then you need a wire that's connecting the two. In order to determine which way the electrons will go, they always travel from A to C, but you can also look at this. Like you have cadmium here, and it's losing electrons, so this is an oxidation reaction here. So it's losing electrons, and so the cadmium here is going to start disintegrating or disappearing because it's forming cadmium ions, more cadmium ions, and the electrons are getting pushed this way. So the electrons are going to be traveling that way, going this way, and those electrons, when they come and hit the cathode, which is made of nickel, what's going to happen is the nickel from the solution, the nickel ion here, is going to pick up those electrons and become nickel solid, which is shown right down here. And so that nickel electrode will become bigger because you'll see more nickel will form on it. The last thing I wanted to show from this was just the, not the charges, but the voltages that happen with this. So, just let me erase that part. Whoops, I erased a bit too much. There was 2 electrons there. You can tell what voltage this cell will produce by looking at the numbers over here on the side. So the nickel number is negative 0.26. So if you don't change how that the reaction is, if it's just written exactly as it is there, I just use that number right there. And so the strongest oxidizing agent or the reduction reaction, you always leave like that one. But this one, the strongest reducing agent, we flip that equation around, right? So this thing, one side became the other side. If that happens, you have to take this number there and switch it around. So it'll become positive 0.40. So to figure out what the voltage of the cell is, you just add those 2 numbers. So negative 0.26 plus 0.40, I think that comes out to a positive 0.40 volts. So that's what kind of electron flow will happen if you put that cell together. And you were right here that this cadmium appeared to be the anode and the nickel part was the cathode. All right, hopefully that answered all your questions. If you have other ones, give me a holler.